Hello friends, welcome back to our channel. So in our previous session we are discussing about the fine tuning. So in that session we have seen we can do the fine tuning either on the prompt or on AI model. So if you fine tune the prompt, definitely we'll be getting the optimized results. And if you fine tune the model, so we have to consider some pre-trained model and we need to retrain that model with a particular aspect that we are calling it as a fine tuning of a model. Now in this session we'll see what are the different types of fine tunings, right? Yes, so types of fine tuning. So the first one is a full fine tuning. Full fine tuning. Okay, so here all the parameters of an AI model will be updated. So all parameters of a model, AI model, will be updated. So updated, or we can simply say trained. Okay, retrained. Now here the question. So you might have the question, what exactly these parameters, right? So let us tell you that thing, right? So parameters which stores the knowledge learned by the model. So we are saying this model will be trained with a large data sets. Okay, so during the training, whatever the grammar, so it will predict some data, right? So that prediction, that means it have to store some information, and that information will be stored in parameters. So if a model is having a more parameters, if model is having a more parameters, that implies accurate output. So will be the AI model will be returning the accurate output. Okay, so simply we can say these parameters are brain cells, brain cells of AI model. So whatever the model, I mean whatever the knowledge or whatever the information gained by the AI model, everything will be stored in a parameters. Okay, so if you are using this full fine tuning, that is the first type of fine tuning. So whatever the parameters available in the AI model, everything will be updated. For example, if this having 1 million parameters, if it contains 1 million parameters, everything will be updated. Everything will be updated, right? So simple example. So if you want to generate some medical reports, okay, if you want to create some medical AI assistant chatbot, so first it should be trained with the lakhs of medical records. Okay, so it will stores and it will updates everything in that existing model. So that type of thing we call it as a full fine tuning. So full means all the parameters of an AI model will be updated, right? Yes, so the next category, hope you understood, right? So the next category, so here the AI model will be fine tuned. Okay, so as I said that the fine tuning can be done on either AI model or a prompt. So in this case, AI model will be fine tuned. The next one is uh, parameter efficient fine tuning. parameter efficient fine tuning. So here the name itself indicates not all the parameters will be updated, only very few parameters will be updated. So few parameters will be updated. See, coming to the full fine tuning, okay, coming to the full fine tuning, FFT means full fine tuning, for example. So it will give 100% accurate results. 100% accurate results, okay, but in order to achieve this full fine tuning, it will be a more expensive. So it requires GPUs in order to complete its training. Okay, so this is the full fine tuning. So let us see this one. Coming to parameter efficient fine tuning, so very few parameters will be updated, not every parameter will be updated. Okay, so here there are three categories once again. So the first one, under this parameter efficient fine tuning, the first one comes with a low rank adaptation. Low rank adaptation. The second one, prompt tuning, and the third one, adapter tuning. So these three tuning process will be comes under this parameter efficient tuning, fine tuning, which trains only very few parameters, not every parameter. Okay, so coming to the low rank adaptation, so here a small trainable layers will be included in AI model. Very small trainable layers will be included, and whenever this fine tuning is done, in this case low rank adaptation, only these trainable layers will be these trainable layers will be fine tuned, not all the things. Okay, so additionally some trainable layers will be added. Okay, and coming to the prompt, here the name itself indicates this, the prompt will be fine tuned. Okay, so prompt will be optimized. Prompt will be optimized based on user requirement. User requirement. And coming to the adapter training, here also similar to this low rank adaptation. So a few adapter layers will be added between existing AI model, right? So few adapted layers similar to our low rank adaptation, and this is a popular parameter efficient fine tuning. Okay, this one is a popular low rank, okay, which is also called as LoRA. So these are very popular. Okay, so in this case only the small trainable layers will be included, and here we can simply say 1 to 2% will be trained. In this case only 1 to 2% of the parameters will only be trained. Okay, and coming to the prompt tuning, the name itself indicates a prompt. So we'll be starting with the basic prompt, and based upon the results and based upon the user requirements, the prompt can also be optimized in order to get the accurate results. So that will be done in a prompt tuning. Okay, so we'll be giving some sort of examples how we are expecting the results, right? So that will be done in the prompt tuning. And adapter tuning, some adapter layers will be included. For example, consider the chat GPT. Okay, so which will be developed in English. So if I want to train the GPT, that particular model, in order to get the results in different languages. So one language, say an example, one language is equal to one adapter layer. So one layer gives the results in Telugu, one layer gives the results in Tamil, and one layer gives the results in Hindi, etc. So such type of adapter layers will be included in the AI model, very few. So whenever we are trying to fine tune them, only those layers will be fine tuned. Okay, so these three comes under this parameter efficient fine tuning, which is also called as PEFT, parameter efficient fine tuning. So hope you understand this one, right? So let us move on with the third category. The third category, so which is instruction fine tuning. Instruction fine tuning. So this is also similar to our prompt fine tuning. So we are giving some instruction to the uh, prompt, I mean to the AI model. So we need to give some instruction before giving the actual prompt. Okay, so instruction is given before actual prompt. See, example, we can say, so if I want to teach the generative AI course for the engineering students, so I will give some instruction before asking the prompt, okay, before giving the prompt. Like, so consider you as an instructor or a teacher who teaches to the first year students or third year BTech students. So need a complete information about the generative AI. So these kind of instructions will be given before giving the prompt. So here the real prompt, the actual prompt is explanation about the generative AI, but I am giving some instruction like consider you as a teacher who teaches the generative AI for the third year BTech students or a second year BTech students for engineering graduates. So such type of instructions will be given. So those instructions will be fine tuned. Even here also we'll be getting the optimized results. Okay, so this is of instruction fine tuning, and this will be useful in question and answers. So we'll be using different prompts or different instructions. I'll write here. Okay, Q&A. Similarly, sentiment analysis, summarization, what not, everything, for everything we can use these kind of things. Okay, instruction based. And finally, the last one is reinforcement learning from human feedback. So here RLHF. So in this case, the name itself indicates based upon the human feedback, the complete results or the complete prompt will be fine tuned and it will obtain the different results. So here the first, what happens, it will generate, the model generates multiple results. We can say them as a choices. Okay, then user selects the choice and based on the feedback, that means based on selection, model will refine the results. So in this case, the refinement will be done based upon the human feedback. So initially it will give a multiple choices to the user, and the user can select the relevant choice. Okay, so based upon that selection only the refinement will be done. So that is called as a reinforcement learning from the human feedback. So these are all the types of fine tunings. So the first one we have seen, which is a full fine tuning, and next a parameter efficient fine tuning, and under that parameter efficient fine tuning we have seen LoRA, that means a low rank adaptation, and prompt tuning, as well as the third one, which is adapter tuning. Okay, and then we have seen the instruction fine tuning, where the instruction will be given so before the actual prompts, and finally we have seen the reinforcement learning from the human feedback, where we'll be getting multiple choices. So from that we can able to choose one choice which is relevant to our prompt, right? So hope you understood these types of fine tuning. So this can be done on a prompt or AI model. This already we have seen in our previous session. So I'll post the link in the description so that you can follow that one. So before this you can follow what exactly means the fine tuning, and then you just come with this video, so then you will be understanding much more. And also you need to understand what exactly the parameters. Okay, we are saying that the parameters will be trained, or the parameters will be updated. So what exactly the parameters, and what is the importance of parameters in the AI model? So each model will be having a millions and billions of parameters. Okay, so those parameters will be updated. So that is called as a fine tuning, right? Yes. So I'll stop here, and if you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.